So they tell us here's the graph of y equals g of x. And then they ask us to sketch the graph. Did I go too quick as I flew away? Yes. People are frantically trying to get the notes from that last little bit. There you go. This question has to be done in function notation only. For one, do you recognize this graph as one of the graphs you have memorized? No. It just looks like a bunch of lines put together. That's what it is. So we have to work only in function notation with this one. It says sketch the graph of g of 0.5x. So first of all, what we're going to do is describe this just like we did in our last example, just to get practice describing. This is going to be a horizontal because it's inside the function, and it's going to be a stretch. Now, when figuring out what factor that stretch is, it might be helpful to change that decimal to a fraction so you can do the reciprocal. A half, if I do the reciprocal, is 2 over 1. It's going to be a horizontal stretch by a factor of 2. Algebraically, that means we're going to multiply our x values by 2. How many key points does the original graph have? 4. So we're going to label all 4 of those points. So we have negative 3, 2. We have negative 1, 5. 3, 3. And 4, negative 2. Draw our arrows to show that we're going to do some work, and above that we're going to describe, we're going to multiply all of our x values by 2. Negative 6, 2, negative 2, 5, 6, 3, and 8, negative 2. And now we'll go to our graph and label all of those points. Negative 6, 2. Negative 2, 5. 6, 3. And 8, negative 2. And connect the dots to get our final graph. Again, once you get your final graph, or while you're trying to connect your dots and you're wondering, well, which dots should I connect, the shape should be similar to our previous shape. Can you see if you grabbed hold of the graph on the right-hand side and the left-hand side and stretched away from the y-axis, that matches up with the graph that you have? So again, you think about the words and the description that you've written and say, does it match up with the shape that I get? State the domain and range of each one, and this time I will use interval notation. So for the domain, I think, what's my smallest x value? My smallest x value is negative 3, and it's included. And my largest x value is 4, and it's included. For my range, my smallest y value is negative 2, and my largest y value is 5. For my green graph, my smallest x value is negative 6, My largest x value is 8. My smallest y value is negative 2. My largest y value is 5. Yes?
Are we going to get graphs on the test or the exam where one of the domain or range is included? So it's not a square bracket.
It is. What will happen on those ones is most likely yes, but it'll have like an asymptote. Okay, an asymptote is an example of where it's not included. The other way that you could make this graph not included is at the end point, if it was an open circle. Then on my green graph, I would write an open circle, and that would cause my smallest value, negative 2, to be a round bracket for my range. It would also cause my largest value of 4 to be a round bracket. So that's what it would look like if it wasn't included. Good question. Yes?
I don't understand how you know if it's like compressing horizontally or vertically stretching.
So the difference between something being horizontal or vertical for stretches is where the number is multiplied by. So in our example here, this was horizontal because the 1/2 was inside the function.
Yeah, I know that part, I just don't know how you know if it's going to compress or stretch.
How to stretch or compress? Anytime that you're multiplying the x by a number bigger than 1, so here we're multiplying x by 2, we're going to say stretch. Anytime that you're multiplying by a fraction, we're going to say compress. And that's for vertical or horizontal. So if I said, oh, let's do another example, and let's do y equals 1/3 of g of x. What does that 1/3 do? First thing we're always going to ask ourselves is, does this affect the x or does this affect the y? Okay? Since it's outside, we're going to say it affects the y. Now we're thinking vertical, so it's going to be vertical something. What would we have to multiply y by? Well, it's outside the functions. Things outside the function act like we think they should, so you would multiply y by 1/3. And since you're multiplying by a fraction, less than 1, that would make it a compression. Does that make sense? Okay. The other thing that this question is going to prepare you for, and the thing that the exam really likes to do, is it likes to ask the same question, but take away a piece of information. Imagine you have a graph of g of x, but we're not showing it to you. You then want to have the graph of g of 0.5x, but you can't see it because you don't know what the original graph is. But what we're going to tell you is the domain and range of the original red graph, even though you can't see the picture, is this. Can you tell me the domain and range of the green graph without having the graph? Why is it that the range stayed the same? Because we're just affecting with the x. Affecting the x. Notice what happens when you multiply the x by 2. Okay? It's getting stretched. So if my domain was from -3 to 4, and it got stretched, does it make sense that it goes from -6 to 8? What's the hardest thing students have with interval notation? They get it mixed up with points. Right? Can you see yourself maybe mixing that up? This is a point. This is your x-coordinate. This is a y-coordinate. This isn't an interval. This is an interval. These are both x's. Right? Because you're going from -3 to 4. So something to think about and realize that you could get those mixed up. Okay, let's practice a couple of these. For these ones, you had question 3 from the previous one you can do, and now 4 and 8.